Okay, welcome back. Hopefully you were able to get that last activity to work. If it did, you saw that from Omaha's monthly mean minimum temperatures in January, there is a statistically significant temperature trend. That's really interesting and important information if one's trying to get a handle on global warming and what it might end up meaning. To get to that point, you discovered that the null hypothesis, that there wasn't a real trend in the temperatures at Omaha, was extremely unlikely given the observations. Therefore, you were able to reject the null hypothesis, which forces you to accept the alternative hypothesis that there is a trend in the mean minimum temperature in Omaha in January. For the main lab activity that you're going to be doing, you're going to develop a pair of hypotheses like these for different stations, different variables, and different months. You'll work through the statistics using the spreadsheet templates that we've provided, and you'll decide whether or not you will be able to reject the null hypothesis for your data. I've worked through the statistics for most of the stations and most of the months, and I want to talk to you about the results that you're going to find. At each station, there are 5 variables, stuff like MMNT and MMXT and so on. And there are 12 months of data. Therefore, each station has a total of 5 times 12 equals 60 data sets associated with it. There are 60 different hypothesis tests that you could run for that station. Here I'm showing you a table of results for all 60 hypothesis tests for, as it happens, Indianapolis. The values shown are the probability that the slope computed could have happened by chance. It's just like the probability that you computed in the last activity. I've marked in red any of the data sets that had values less than 5%, meaning that those are the ones for which we can reject the null hypothesis at the 95% confidence level. Those are the ones for which we have proven that there is a statistically significant trend because we have to reject the null hypothesis. And you can see that we can reject the null hypothesis for lots of the variables and for lots of the months. That's really interesting and important, right? I mean, we have now proven, using extremely reliable data and techniques, that there are long-term temperature trends for much of the year for many of the variables in Indianapolis. That has to mean something, right? As I said in one of the earlier videos, that doesn't exactly tell us why the temperature is increasing. That takes different kinds of experiments and different kinds of statistical tests. But from a scientific point of view, for any of the months and variables marked in red, there is no real question. There is a temperature trend. But notice that there are some months and some variables for which we cannot reject the null hypothesis. For those data sets, the data simply do not have a big enough trend for us to conclusively reject the null hypothesis and accept the alternative hypothesis. Remember, we can only reject the null hypothesis if B, the slope of the best fit line, is bigger than would have occurred by chance. For the data sets marked in white, we can't do that. The trends in the lists of random numbers are sometimes that big. We can't reject the null hypothesis that the data do not show a trend. But here's the thing. That's not the same thing as saying that therefore there is not a trend in the data. We're just saying that we cannot reject the idea that there is no trend. For example, maybe the trend in the temperature data is just small but real. In a relatively short data series, a small trend will be very hard to find. Much harder to find than a big trend, right? The statistical test that we've used in this lab activity, this test of the slope of a best fit line, is extremely straightforward. It's relatively simple and relatively simple to explain. It's a powerful tool. But when the trends are small or the data sets are short, it can be, let's say, not the right tool for the job. There are more powerful tests that can tell us more about the warming that may or may not be happening at Indianapolis, even in the months that do not show a statistically significant temperature trend. For example, take a look at this table, which shows the actual trend that I computed for all 60 of the data sets associated with Indianapolis. These temperature trends are shown in degrees Celsius per century. For some of the months the trends are big, and some of the months the trends are small. For some of the trends are positive, for some the trends are negative, indicating that the temperatures are actually decreasing with respect to time. It's a lot of data. But look what happens if I mark just the ones in which there is a positive temperature trend, suggesting that the station is warming with respect to time. Out of the 60 data records shown, 48 of them show warming. In fact, all 12 of the months show a positive temperature trend for extreme minimum temperature and mean minimum temperature. That's not very likely to have happened by chance. Remember, if there isn't really a temperature trend here, we would expect that the value of B would be positive half the time and negative half the time. But that's not what we're seeing. For example, 12 out of 12 months of the year show a positive trend in extreme and mean minimum temperatures in Indianapolis. That's extremely unlikely. The odds of that happening by chance are about 0.02% as it happens. For that matter, the odds that 48 or more of the 60 trends would be positive are really long. The odds that this could happen by chance are roughly 1 in 100 million. We didn't learn how to do tests like that in this lab because, frankly, this activity has more than enough steps and enough stuff to learn. The basic test is a powerful tool, and you're learning a lot about how science is done, but fancier tests really don't leave room for valid doubt. In this case, the case of Indianapolis, the temperature has been increasing. Case closed. But you can see how this leaves room for the folks who want to deny climate change and global warming. I mean, going back to the table of all the results of all the hypothesis tests for individual months and temperature variables, yeah, if you wanted to say that the temperature was not increasing, and if you weren't all that worried about being honest or being shown to be wrong about that, you've got something to work with here. Somebody like that could certainly say or write something like this. I don't believe that there is warming in Indianapolis. I computed a statistical test of mean temperatures in June in Indianapolis, and the test showed that we cannot conclude that there is any trend. And strictly speaking, this is not entirely untrue. If you look at the results for mean temperature in June in Indianapolis, you'll see that we were not able to reject the null hypothesis that there is no trend, because the computed value of B, the slope of the best fit line, was not all that big. It was small enough that trends like that occur in lists of random numbers. Well, only about 9.55% of the time, but admittedly sometimes. Someone who wanted to use this information to argue against global warming would be misleading you, though. Firstly, notice that this person had to pick and choose which data and which month and which variable to show in order to get the results that he wanted. Secondly, the data aren't showing that there isn't a trend. They're showing a small trend, a trend too small to be seen unambiguously in a relatively short data record. With this data, we cannot be certain that we can reject the null hypothesis, but that's not the same thing as saying that the alternative hypothesis is false. Just because we cannot rule out the null hypothesis doesn't mean that the null hypothesis is true. It just means that we would need more data or different kinds of statistical tests to prove the point one way or the other. Whether through a legitimate misunderstanding of what the statistics are telling them, or through a deliberate attempt to misrepresent the facts, folks who argue against the reality of global warming have latched onto incorrect interpretations of these statistics to make the point. And this has led to a lot of misunderstanding in the public about what's going on with our climate. But the facts are the facts, and the scientific hypothesis tests work. There isn't really any more doubt anymore about this. At most locations on Earth, the temperature is increasing at a rate of a few degrees Celsius per century. For some locations, the trends are bigger, and at other locations, the trend is smaller, but the evidence is clear that something is happening to our climate. And to be clear, very few scientists or scholars disagree with that assessment anymore. You find debate about whether or not global warming is happening, but those aren't really scientists. They're generally politicians or celebrities or whatever, people who don't necessarily have the facts or are ignoring the facts. From the point of view of science, the world is warming, and we know this in the same way that we know anything else in science. None of this, of course, answers the question of why the planet is warming. Again, one can agree with the facts and the statistical results and say that global warming is happening without agreeing that the warming is due to human activity, such as the burning of fossil fuels. That's a completely different question And it again takes a different kind of scientific experiment to get to the bottom of that. As it happens, those kinds of questions have been the subject of serious scientific research for decades. And again, the scientific community is largely in agreement on this point. While there is still some wiggle room for different interpretations, there is a strong consensus that the warming is being caused primarily by human activity. Legitimate scholars can still have some disagreement on that point after surveying the data and understanding what the results mean. But really, we have a smoking gun here. If human activity isn't causing the climate change that we're seeing in the data, we as climate scientists apparently have some pretty fundamental misunderstandings of how the atmosphere works. And that's just not very likely at this point, as our understanding of the climate and the atmosphere has served us well for lots of other applications, like forecasting. But here's one last point. None of this tells us what to do about global warming. Science can provide answers to certain kinds of questions. Science can tell us what is happening. Science can tell us what is causing the effects we are seeing. Science can even tell us what will happen or may happen if we do or do not make certain kinds of changes. But science cannot tell us what to do. That's a matter of policy, and global warming policy is a completely different problem. That involves politicians and donors and constituencies and diplomacy and economics and ethics, and that's complicated. That stuff makes figuring out the business of the magnitude of long-term temperature trends in the United States look pretty simple, right? But you've got an entire Creighton education to figure out how you are going to be a person for others. You've got an entire Creighton education to decide how you're going to be greater. Figuring out how you are going to use information to be that person, that's what you have to work out. But that's not this lab, right? For now, you just have to finish up this lab activity. The rest of the lab is done in the classroom. Your TA will work with you to develop and test some scientific hypotheses. Hopefully all will go smoothly for you. If you have any questions about any of this, please feel free to contact me or your TA. Good luck with that lab.